All right, today we are diving into something huge, a truly radical new theory that's trying to crack the cosmic code itself. And what it suggests, well, it could change everything we think we know about the universe. It's this idea that the biggest mysteries in physics, they might not even be real mysteries. Maybe they're just illusions. So, yeah, let's get into it.
Just think about that for a second. What if all the stuff we spend billions of dollars searching for, things like dark matter, what if they aren't actually things at all? What if they're just shadows, echoes of a much deeper reality? That is the absolutely mind-bending question at the core of this new framework, a framework that's trying to finally unify physics. It is a massive claim for sure, so let's see if it actually holds up.
For decades now, modern physics has been staring at these huge, glaring cracks in its own foundation. We pour all this effort in, and we still can't explain what dark matter is. We have no real clue where dark energy comes from. We've got all these fundamental forces that just refuse to play nice with each other. And of course, the big one. We are still desperately searching for a single theory of everything. These are the massive puzzles that literally keep physicists up at night.
Okay, so into this mess steps this new theory. And it looks at all of these seemingly separate problems and proposes something genuinely radical. It basically suggests we've been looking at the whole thing completely backwards. That instead of needing a dozen different patches and constantly inventing new particles to plug the holes in our models, what if there's just one single fundamental mechanism that explains the whole shebang?
And that right there is the core of this whole thing. It's called the one mechanism hypothesis. The big idea is this. The universe doesn't have separate rule books for gravity over here and quantum mechanics over there and cosmology somewhere else. No, it has one master set of organizational rules. Think about that. The exact same fundamental logic that builds a tiny proton is the same logic that builds an entire galaxy. It just looks different to us because the scale is so wildly different. It is, without a doubt, one of the most ambitious attempts to unify physics ever proposed.
So, okay, if the whole universe is running on just one set of rules, the next logical question is, where are those rules written down, right? Well, this is where the theory introduces a really fascinating concept called the metapole. Now, fair warning, this is where things get a little abstract, so stick with me here. The absolute best way to wrap your head around it is to think of it like a cosmic operating system.
And this is absolutely crucial to understand. The metapole is not a place you can go visit. It's not some parallel dimension. It's better to think of it as a totally non-physical layer. It's the fundamental source code that our entire reality runs on. It literally defines the rules of the game. And everything we see and experience, space-time, matter, energy, all of it, is generated from that code. It doesn't exist in the universe, it creates the universe.
So what you end up with are two very different layers of reality. On one hand, you've got the metapole. That's the complete underlying source code. It's super information-rich, totally deterministic. But then you have our physical reality, the world we live in. And that's like the program being run from that code. But, and this is the absolute key to the whole theory, what we get to see, what we can measure, is just an incomplete projection. It's kind of like you're watching a movie on a screen, but you never get to see the script, or the actors, or the director, or any of the behind-the-scenes stuff that actually made it happen.
Right, we only ever see this blurry shadow of the real code. And the theory has a name for this. It's called observational projection. What it really means is that all the physical laws we write down, all the particles we smash together, all the forces we measure, they're basically just blurry, low-resolution shadows of this unbelievably more complex code that's running underneath it all. A ton of information gets lost in translation, so to speak, when it projects from the metapole into our physical world.
And look, this isn't just some neat philosophical idea. This is all formalized with actual mathematics. What you're seeing here is how it works. A complete structural state in the metapole, let's just call that sigma, gets passed through what's called a projection operator. And that spits out the reality that we can actually observe and measure. We'll call that y. And the really critical thing here is that the math itself proves that this projection is a one-way street. It's irreversible, and it always loses information along the way.
Okay, so that's all pretty mind-bending stuff, right? But the big question is, what's the payoff? So what? How does this whole idea of a hidden cosmic code actually help us solve any of the universe's biggest puzzles? Well, let's see how the theory takes a crack at the big ones, and we're going to start with the heavyweight champion of cosmic mysteries, dark matter. So the standard view, the one we've been working with for decades, is that dark matter is some kind of mysterious, invisible stuff, some particle out there that we just haven't been able to find yet. But this new framework comes along and says, forget the stuff. It says dark matter is not a substance, it's not a particle, it is an effect. It's like the gravitational ghost of the metapole's incredibly complex underlying structure. So that extra gravity we see holding entire galaxies together, that's just a projection of the hidden code. It's not missing matter at all.
So how does that actually work in practice? Well, instead of inventing a whole bunch of new exotic particles, the theory does something much simpler, much more elegant. It just modifies Einstein's famous equations of general relativity. It adds one single new term, you can see it right here, T meta. And that little term represents all the energy and momentum coming from the metapole's hidden structure. So it's a mathematical fix, not a material one. It's incredibly clever.
And you know what? The exact same logic applies to dark energy. You know, that mysterious force that seems to be pushing the entire universe apart? The theory says it's not a force at all. Surprise, surprise, it's just another projection. But this time, it's the effect of the metapole's global dynamics playing out on the biggest cosmic scales. And just like that, two of the absolute biggest mysteries in all of physics are potentially solved. Not with new stuff, but just with a new, deeper layer of rules.
Okay, a wild new theory is one thing, and this is definitely a wild one. But in science, ideas live and die by one thing and one thing only: their ability to make predictions that can be tested. So the real question is, does this theory actually put its money where its mouth is?
Because, this is the absolute cornerstone of the scientific method, right? For any theory to be more than just a cool story, it has to make a specific, testable, and falsifiable prediction. It has to give other scientists a way to try and prove it wrong. And thankfully, the people behind this framework understood that perfectly.
In fact, they went so far as to build a formal pass-fail protocol right into the theory itself. What that means is that every single hypothesis that comes out of this has to be tied to a super clear test with a completely unambiguous condition for failure. There's no room for waffling here, no moving the goalposts later. This is a really serious commitment to scientific rigor, and you love to see it. And this, well, this is pretty much their smoking gun. The theory made a very specific prediction. It said that if you plot the masses of certain families of particles in a very particular way, they should all fall on a simple, straight line. It's supposed to be a direct reflection of that underlying code. So they did it. They plotted 3 known particle structures, those are the blue dots you're seeing, and what do you know? They formed a perfect line. And that perfect line allowed them to make a blind prediction for where the next particle in that family had to be. That's the orange star. And they didn't just say, oh, it's somewhere up there. No, they put a hard, precise number on it, 7,715 mega-electron volts. That is a specific, testable, falsifiable prediction. And here's the really incredible part. Very recent experiments have started reporting the discovery of new particle structures right in that exact energy range. Now, it's still early days, but that's some seriously powerful early support for this whole model.
So what's the big takeaway from all of this? The really crucial point is that we might be standing on the verge of a massive paradigm shift in physics. A shift away from a universe filled with this messy zoo of different particles and mysterious forces, and toward a universe that's governed by a single, elegant, and universal code. Look, the evidence is only just starting to trickle in, but if this holds up, the implications are absolutely staggering. And that really just leaves us with one final, pretty provocative thought to chew on. If dark matter, something we thought makes up most of the matter in the entire universe, turns out to be just a shadow of this deeper code, then what else might be an illusion? What about our sense of time? What about consciousness? The very fabric of reality itself. You see, a great theory doesn't just answer old questions, it forces us to ask entirely new ones. And that's exactly what this one does. Thanks for diving into this with me.